Okay, so let's continue with our next video in our coding exercise series. So the question is jumping on the clouds revisited, and it is on the hacker rank. It is the easy category question. So let's read the question. A child is playing a cloud hopping game. So you have one child which is playing some game, right? Cloud hopping means like is moving from one cloud to the another cloud. In this game, there are sequentially numbered clouds that can be thunderheads or cumulus clouds. Alright. The character must jump from the cloud to cloud until it reaches the start again. So they said like you have some clouds. As an example, you could see you have some cloud in a circular manner, and you have, let's suppose, this character. All right, this is a child, and this child is jumping, like maybe he's from this to here to here to here, he's jumping, and he will jump until when he is not going to reach till the starting position. And you could see we have the cloud, and we have the two types of cloud. One is thunderheads and one is cumulus. Cumulus mean like a kind of a silent clouds. Thunderheads when we have the like the thunderstorm kind of thing, right? So if the clouds is silent, they are representing by zero. If the clouds are kind of a thunderbird, it is represented by one. There is an array of cloud, right? So you could see you have array of the cloud. So uh, in the starting with c0, say 0 is 0, which is like a, you got a silent cloud, normal cloud, again 0, then 1, which is a thunder heads cloud, then 0 0, then again 1 1, and then 0. So you have like a total eight clouds. And we have the energy level given is equal to 100, because when the child is going to jump from one cloud to another, he needs some energy, and once he jump, he is also consume some energy, right? So we are going to reduce some energy, so the energy level is 100, so E will be 100, will be remain constant, so E is 100. The character start from c0, so you have so many clouds, right? So from which place the character is going to start from jump? So the character always start the jump from the zeroth cloud, so he is always going to start from here. All right, so he's going to always start from here. Okay, now and uses 1 unit of energy to make a jump of size k. So he is going to unit 1 unit, so this is total 100 unit of energy is given, and he's going to consume 1 unit of energy to make a jump of size k. So as an example, if k is equal to 2, so index 0, so if he take one jump, so it will reach here. All right, so how much energy left? 100 minus 1, 99. Then again 2, he will reach here. All right, so how many energy left? So not 100 minus 2, 100 minus 1, 99, and 99 one is for 98. Then again from here to uh, here. All right, so this if I am reading only the half part of the question, all right, so then 99 one minus 98. All right, so that is the normal scenario, but there is a one catch given, not a catch, one more basically condition given. So this is the starting point. They mention if the character lands on a thundercloud, that is where we have C of I is equal to 1, then we need to reduce the energy by 2 additional units. So basically what was happening is what was happening is uh, so 0 2 4 1 2 3 4 5 6 7 8, and then 0 से 2 2 से something is wrong, 0 से 2 2 से 0. Oh, I forgot to add. No, 538. Okay, it's fine. So you could see So it is going to back here, yeah. So it is mentioned if it is going to reach at first on the cloud, which is a thunderhead, then you need to reduce additional 2 unit of energy, and the game is going to end when the cloud reach back to the back on the cloud zero. That is on the starting point, and we need to return determine the final value of the energy after the game's end. So let's suppose it start from here, right? Because anyhow it's going to start from zero. So k is 2. So if k is 2, so it means take like a 2 jump, 0 plus 2, so it will reach here. It will reach here. Uh, so if it reach here, it take one jump, right? So the energy will be 100 minus 199. Then we will check, okay, uh, whatever the position the character reach, it is a thunderhead. Yes, it is a thunderhead. If it is a thunderhead, then we are going to reduce additional 2 unit. So now the final energy is 97, right? So, but it is not a starting position. Then again, cloud will jump 2 more unit. So it will reach here, right? 1 and 2. It will reach here. So if once it will reach here, uh, then we will going to reduce one more energy, 97 minus 196. But it is a thunderhead. No, so we are not going to reduce additional 2. Then again 2 more jumps. So now it will reach here. All right. So 4 plus 2 6. So it will reach here. Basically the index. So this is the fourth index, this is the sixth index. So we have the energy 96. So because it take one jump, so 96 1 minus 95. But it is a thunderhead, so we are going to reduce uh, 2 more, so it will become 93. It will become 93, right? So now, so once it reach here, once it reach here, it will make one more jump. So 6 plus 2, 8. But we don't have any eighth index. All right. But as of now, we don't have any eighth index. So, but it is a circular fashion. That's why they have mentioned when it's going to jump, we have to use this formula rather than I plus k. Because if you do just I plus k, then it is going to reach at eighth index. We don't have the eighth index. Eighth index is basically the starting position only, right? So it is a zero indexed. So you always have to do the modulus of n. So modulus of n only we do when we have the circular fashion, right? So it reach here, uh, and because it is not it reach here, so 95 93 minus 192. All right, does it a thunderhead? No, so the final answer will be 92. So it's a straightforward question, not a very tough question. So let's try to directly jump, write the code, and hopefully you are going to understand more. So energy is equal to 100. We have like initial energy given is equal to 100. From where we need to start? We need to start from the I is equal to 0 position. All right. Okay. While true, because we don't know how many jump we need. All right. So while true. Now, so we have to find the next position. So uh, it start from zero. It start from zero. All right, so we need to find the next position. So how we will calculate the next position? So I plus k is the next position, but because it is circular, we will do modulus n. So this is something they have already provided to us. So what will be the next position calculated? How the next position will be calculated? I plus k modulus n. So we found I plus k modulus n. Okay, then we are going to reduce because it already took one jump, right? Because we already took one jump, because we already calculated the next I, so we have to reduce the energy. But we have also have to check if C of I, whatever the new I, equal to 1, then we are going to reduce additional 2 unit. We are going to reduce additional 2 unit. Okay. And if we will check if I is equal to 0, then we are going to break, because this is a while loop. While true, we have to break. And when we have to break, when it is going to reach at the starting position, because we start from the 0. So if it is again reaches at 0th index, then we are going to break, and we are going to return the remaining energy. So let's try to run the code. So sample test case has been passed. Let's try to submit the code. So all the test cases has been passed. So it's a straightforward question, not a very much difficult question. What the question said is, start from the zero. You have the total energy, and take a two jump. And in as soon as you do one jump, not a two jump, basically take a one jump, but of size k, and he's going to consume like one energy. And but if the destination is the thunderhead, then it is going to take two more additional energy. The same thing we are going to take. So we take energy is equal to 100, starting will be 0. So while true, because we have to take continuous loop, because we don't know when it is going to be end. So while true, so we will find, okay, what is the next position? So next position is I plus k generally, but because it is circular, so we have to do modulus n. Even you don't know modulus n, we can just get from the question, because they have mentioned I plus k modulus n. Okay, so because we already took the one jump, so we will reduce one energy, one unit of energy. So energy is equal to energy minus one. And then we will check, okay, if the destination is whatever, wherever he reach, it is a thunderhead. Basically, if cloud of I, C is a cloud of array, so C of I is equal to 1, then we are going to reduce additional 2 unit of energy. All right, then we will check if the destination is the starting point. All right, so we will check if the destination, if I is equal to 0 index, no, it's not the starting point. Then this loop is going to like continue. So here, and when it reach here, we will check if I is equal to 0, yes, we are going to break, and whatever the energy we have left, we are going to return. So that's it. That's the end of the video, and thank you.